Welcome in the second section. We'll learn about basic principles of reinforcement learning, and also we saw the API that we'll be using in this section to solve a Cartpole problem. So this is a section about solving Cartpole with Markov decision process. So firstly, we'll try and understand Cartpole problem. This is a problem that is well fitted for reinforcement learning, and if you will go to every reinforcement learning tutorial or library, it will explain the principles of reinforcement learning based on this example. So this is very useful to understand that and then to be able to learn using this example. Then we'll be leveraging Markov chain in our Cartpole solution. First video we'll be configuring QL configuration for our model. So we'll use an API that we saw in the previous video, so last one in the section 1, to configure our model. Then we'll be using gym environment library from RL4J to simulate our solution. So we'll be using gym-env to make a state and to take that state into the abstraction of RL4J library. Finally, we'll be running Cartpole and validating our results. So this is a first video in which we will be understanding Cartpole problem. So we'll see what a Cartpole problem is, and also we will answer a question why reinforcement learning is a good choice for that problem. Why this is a problem that is almost always picked as the best use case for reinforcement learning. But before we'll start coding in the subsequent videos, we'll need to define reward and state. So we'll need to define what a reward is in our problem and what is a state that then could be presented as a gym-env. So let's take a look at this diagram. So Cartpole is known also as an inverted pendulum and is a pendulum with a center of gravity above its pivot point. So dot at the middle of the square indicates a pivot point in this specific diagram. The problem with Cartpole is that it's unstable, but it can be controlled by moving the pivot point under center of the mass. So as you know already, center of the mass is in that middle point in our Cartpole. And the goal of our algorithm will be to keep the Cartpole balance by applying appropriate forces to a pivot point. So you need to keep that pivot within a specific axis to make it balanced. Finally, X in this diagram arrow shows possible horizontal forces that can be applied to a pivot point. So our goal will be to move the specific Cartpole to right or left within that x-axis to make our pivot point balanced. So in this example, our Cartpole is a state. Our action will be moving that Cartpole into right or left direction, and the reward will be keeping our Cartpole balanced, so keeping it vertical. So this is a problem that we need to solve in our reinforcement learning algorithm.